you may have all the technology and you may have all the problems solved, but the user experience, like people just want something more all the time.
They always want something more.
Yes, for example, security was a set of things that had not been really thought through in the 90s.
Is there anything you think that's going to be groundbreaking today, but it's just going to become normal expected behavior in the future from these tools?
And we knew that video would become really big, which, I always thought would be happening much before it actually happened. We needed a pandemic for it to
that kicked it off big time.
Unless you're a big company, you build the algorithm and the algorithm sits inside your thing. It's your secret sauce kind of thing. And the algorithms are all everyone else's. But how do you know if those algorithms are doing a good job?
Hello, and welcome to Tech Effect, the podcast where we interview industry leaders and experts on the topics and trends shaping the tech industry. My name is Josh from TestDevLab's marketing team, and today I'm joined by Dr. Varun Singh. Varun has over 2 decades of experience in software development and is currently the Chief Product Technology Officer at Daily, the real-time voice, video, and AI platform for developers used by Fortune 500s and startups alike. Varun's current work has been focusing on developer time to value, core quality and reliability, and APIs that cover the largest possible set of use cases. Outside of his day job, Varun is also a standards contributor. So it's a pleasure to have this very experienced and, fair to say, an authority on the real-time video tech domain and joining us today. Welcome to the show, Varun.
Thank you, Josh. It was a pleasure to be here. Thank you, TestDevLabs, as well, for hosting us.
Thank you for coming. It's always a pleasure to have someone like you in the office.
And I love Riga, so.
We all love Riga. It's fantastic.
Yeah, it is.
So thank you for joining us. Now, Varun, as I alluded to in your introduction, you have over 2 decades of experience, hands-on experience in tech with a heavy focus on AV. So our audience can learn a little bit more about your journey, I'd like to kick off the conversation by taking it all the way back to the start and ask you what got you interested and started in tech and specifically audio video?
It's interesting. So tech in general, I started when I was a kid. I started to play with computers, and my dad was in the Navy, so we had access to high performance devices around the house. So programming came naturally in that sense. There's no question where how did you get involved? It's if you have things around the house, then you just start to use them, and that's how I got started. Went to school. Graduated, got my first job. It was in the backdrop of the first bubble. So 2000 was the bubble. 2002, people lost jobs. I graduated in 2004, so it was just the recovery period after the bubble. So it was the best time to graduate in that period of time. And I got started with embedded systems. So I did an internship at LG Electronics, and then I got my first job at ST Microelectronics. That's one of the top 5 semiconductor companies, maybe 10 now. There are too many of them around, but and they were building smartphones. So this is 2003, 2004. At that time, smartphones and feature phones were not very different. Smartphones were there, they were expensive, and feature phones were, with
the sliding screens.
Not yet sliding screens, but this feature phones were just simple, cheaper phones. But the technology always was for example, what I started in embedded systems or in these things was with the camera. And so a megapixel camera, which was the top of the line at that point, was in let's say the best phones, and then you had the smaller cameras in the feature phones, and the technology would always percolate down, right? So 1 megapixel become 5 megapixels, then more cameras got added. Now you have 3 cameras or 5 cameras, and if you remember, Nokia and back in the day had 7 cameras at one point on that. So I went to ST, worked on their megapixel camera, which turned out to be a 5 megapixel camera. Then I pivoted over to Nokia. That's what brought me to Finland. And I did my master's there and then subsequently PhD. And all of that was, so to your question, how did I get involved? I knew how to program, got into embedded systems, started writing device drivers for cameras on mobile phones. And then you could just say I went up the stack. Right?
And you just naturally flowed up.
Yeah, so you're from hardware, software core design, then software. And if you think about like the cool part of cameras initially was the hardware, but then more and more it's about software. You like capture in RAW, you like do post-processing, white balance, all of that. So like all those features need to exist in the hardware, but then you need to like do, you have to build apps which can edit these things. So you go one layer up. And as you go up, the complexity increases of what you're trying to do. So it's not just setting white balance, for example. But then if you think around the same time, Instagram, all these things came out. So you had filters, which were presets, as you may think about them. So you start to build on those. And the juxtaposition for this is that you have cameras which can capture pictures, still pictures, and then you do videos. And at the time when I started, you could only do 10-second videos on phones.
Oh, wow.
Like that was it. Like that was the memory that the phone had. Like it had more memory. It's just that you did not want to shoot like 4 minutes video and then be out of memory at all, right? And the SD cards and all these things were still emerging. So the typical thing was you shot 10-second videos, then I would say cloud backup, but there was no real cloud backup. You would like come back home, transfer it to your computer, and then go out and shoot more, right? And then those 10 seconds became like, now there's no cap on recording. But now we have the same thing, like there are services which like bring you back to that same kind of methodology where you can shoot like as much, but TikTok videos used to be 60 seconds.
Yeah.
Right now they're like 3 minutes or 5 minutes. And so we've seen like the same constraints be imposed again for different reasons. So that's what got me started. And once you had like still pictures and videos, then you were like, how can you do video communication, right? Can I talk to the other person? And this is like when it's around the same time Skype came out. Skype did audio for the longest time. Then we were like, hey, can we do videos? And even if you could capture like videos at HD quality, you could not transmit them at HD quality. So you started with like these postage stamp videos being like used because the screens were also so small, right? Like, so you couldn't actually do HD. There were not enough pixels to like render. So there's no reason to capture at that. So it all comes down to like video has kind of like goes in circles. You have streaming, you have real time, and then you go back to streaming because you want higher quality video. We used to have TVs and TV channels, and now you have streaming services.
No, that's true.
So like we just basically keep reinventing, and now you have doom scrolling, right? Like it's the same. It's like not
Guilty.
Netflix anymore, but you want to have you're watching lots of clips very quickly, one after the other, and the interface allows you to like switch super fast. And so you may have all the technology and you may have all the problems solved, but the user experience, like people just want something more all the time.
They always want something more.
Yeah, so the technology has to catch up to like allowing for it.
It always does. I think the smallest one I've seen, specifically for my wife, because she watched a lot of those long form TikTok videos, is you can now double speed them. So it's even faster now. It's not just next content, it's also current content, faster, double speed, and then the next.
Yeah, you don't have to, like earlier you had to hold it, I think, and you don't have to hold it anymore.
We're getting very advanced.
Yeah. I mean, those are the things that people want, right? And then I think from like a technology perspective, you're thinking like, oh, if you're doing doom scrolling, you have to be able to like download a playlist of videos onto your phone, like 10 videos out, because you don't know if the person's going to like just skip. So, and if it stalls, right, and it's downloading the rest of the playlist, then people will stop using your app. They'll go to another app which does that better, right?
Exactly.
So there's always that aspect, the latency of first paint, as you would call it, like is the thing that we all care about. And depending on what type of app you're building, it becomes more interesting.
More interesting, more complex. That's really interesting. And I like how you started with like, it was just the standard childlike interest of when a child has a toy, they want to figure out how it works. They play with it. They do that. You had computers and you knew what you were doing. And then just naturally as the system and the environment evolved and people wanted more features and more things, you went along with it, and you've always been on the edge of, well, okay, we need better cameras, we need to be able to do videos, we need to go to Skype. You've all done that. Was there any one thing that had the biggest impact on you? Was it moving to Finland? Was it working with Nokia? Like, what was the biggest impact there in your journey? Or maybe there's many.
Yeah, I think you make a lot of decisions, and some of it's very hard to say like which one had like, of course retrospectively you can always say like, oh, this one had. I think for me it was of course being in Finland and working in research was interesting, but getting involved in the standards before standards emerged to be like the player. So WebRTC started in 2010, 11, 12, like kind of depends on who tells the story in what way. But I got involved in standards in 2008-9. And so by the time WebRTC started to show it's emerging, like we need something like that, I was already like in the space.
You were in the space.
So, like if I started a little bit later, you would be like, oh, there are already people doing it. So you kind of like help contribute in different ways. I had the opportunity that I was doing research. I was not at Nokia anymore in that sense. So being at a university gave me the opportunity to work with everyone. Like I could go speak to folks at Google, at Skype, at Microsoft, at FaceTime, or, like at any of these locations. And because if you are a neutral university grad student, like people are very happy to talk to you and like tell you what problems they're trying to solve. Maybe you can help them solve some of these, and they're very open because you're not competing with them in any form, and you're like a student, right? Yeah. So like so that actually was really helpful in that way, that I got exposed to some of these problems from like my life at before grad school in the industry. Like I knew like what problems were interesting, already had a knack for them. So I had like a way to like say, oh, I know. And then you get like kind of validation that these are still issues that people want to resolve. So it allowed me to kind of build my research around that. And that actually helped because when I was close to graduating, I had the opportunity to like go back out and say like, hey, maybe I'm thinking of a job. I'm thinking of doing something by myself. It was also after the 2008, 2009 banking crisis. So people were, the economy was re-emerging, and people were thinking about, startups globally. Like, of course, even in Europe, people were like, what is the next big thing? How do we get out of this crisis? How do we build? And companies are one way to do that, is you build companies. A lot of people try a bunch of things. Some of them will succeed, but you kind of get momentum in that direction. So call stats, which I think we'll talk about in a bit, but was one of those things that I was graduating. I was working with WebRTC. I was seeing a bunch of companies build video products, and I was like, oh, I want to build a video product as well. And I looked at EdTech, I looked at healthcare. Some of that was around the aspects of you have to have like industry knowledge to like kind of break into some of the stuff, and some of it is like EdTech is kind of hard. You can now say it is definitely hard because you have people who will pay or not pay for it or want it at the lowest price point. So it's kind of hard to build a business where you either get like long tail, like you get a billion people using it and you get a fraction of, but cost of video is kind of hard. So, and then healthcare has its own like regulatory things.
Whole different world.
So that's how like when I was graduating, I started to look at it and say, okay, what can I do? What can I do to like expand?
Yeah. And as you've talked about a bit, you've worn those many hats. You've been a researcher, a founder, the standards contributor, now chief product technology officer at Daily. What was the thread that connected all those roles? We touched on it a bit. You were in the space, you were talking, you were looking around. But how has that shaped your approach to building this real-time communication? You've had all these little spots, you've seen all these things, you've talked to all these people. What was the common thread that helped you sort of say, this is what we should be doing when we're building these real-time technologies?
I think everyone is different. So I think some people might say, so for me, it was always, I love change. So, I graduated, I worked at a company, and then I said I want to do research. Then I did research, got a PhD. Then I was like, oh, I want to be an entrepreneur, then do that. You could say those were like the logical things to do, but it was also like some things present themselves. And I could easily have been a professor as well, right? So like I could have said, oh, I want to like work on just research, and I could have been a decent researcher as well. So
I believe you.
So it all comes to like what you want to do, and if you're flexible to like kind of change your mind about it. So for me, it was, oh, I finished my PhD. Let me look at what is out there. And in speaking to so many folks and even trying to get a job, I realized that a lot of people were looking at call quality. And there's always this bias, right? Like if you come from the call, like my PhD was about making video better, adapting video quality to different modalities, so networks or screen sizes or what have you. And when you go and talk to people about it, the world reflects on your knowledge and says, okay, can you help me solve? I know your knowledge. Can you solve this problem for us? And if you talk to many people, then the thread that I saw was, oh, if the Googles and the Apples are like asking me this question, maybe there are more people who will want something like that. And you say, okay, am I going to sell algorithms? That's kind of hard, like, because it's kind of, unless you're a big company, you build the algorithm and the algorithm sits inside your thing. It's your secret sauce kind of thing. So and there are cases where people have sold algorithms or people use algorithms which are publicly available. So I chanced upon the idea that maybe measuring, the algorithms are all everyone else's, but how do you know if those algorithms are doing a good job? And we had the same thing 10 years before, like in the early web. You wanted to know the performance of your websites. So you had like the Google Analytics and like a host of analytics products, which you put a small JavaScript into your web app and it measures like page load times, bunch of things like who came, when they came, what they did, how many clicks they did. There's so many metrics from it. And we said, oh, this is green field. We've not done, like, if WebRTC makes it possible for us to like do this on the web, I'm sure like the TV folks, like when you switch channels and such, those people are measuring something. Maybe not, but IPTV, they could be measuring it. And like on Netflix, they probably are, the streaming, they're measuring a bunch of metrics. So we would want different but similar metrics for video calls. So we started to build that. And it so happened that in the same time, you had like things like Slack, like team collaboration apps became more diversified. There was not just the Googles and the Hangouts and the Skypes. There were like new things that emerged. People wanted to put video calls in every place, and we knew that video would become really big, which I always thought would be happening much before it actually happened. We needed a pandemic for it to like...
That kicked it off big time.
So like, to the point where, we were doing... if you talk to people in 2018 and said, like, how many video calls will anyone do legitimately in a day? You would say, like, maybe 1 hour.
Yeah. Quick one, just like at the end of the day.
Yeah, like, but why would anyone do it? It would be like, oh, I could not meet that person, or you're talking to a customer who's far away. People used to fly to meet customers, right? And like, video calls were just like, was just a means to an end.
It's a convenient little, if I don't have time to fly out, I'll just call them on the video thing.
Yeah, and you have that or you've already met them and you're like kind of... You've already set up a relationship, and now you're doing like weekly check-ins or something, and those are... But during the pandemic, we were
that was the norm. That was how it had to be done.
Yeah, we did like to 10 hours to the point where people were like, 100 people on a call was like normal completely. And so we pushed the boundaries to the point where I think we went beyond what we even hypothesized in terms of like what people would do, which was great for the technology. The technology moved like at 100x the speed in like... It was already there, right? Like we were able to actually go and do the pandemic remotely, partly because like VPNs existed, internet was everywhere. not only on your phone, not only in your home, in your phone,
in your laptop, in your everything.
Yeah, so you had access to it everywhere. You had like gigabits of, or at least hundreds of megabits of bandwidth. 4 people at home could potentially stay and like do school, do work, watch videos, play video games. You could push
everything to the
limit. So I think, and we survived. Like in some sense, we survived it. So like the technology did prove that we were capable of doing it, and we built it well enough.
Did it well.
Yeah.
I think one of the things you were probably talking about there was one of your big success stories was callstats.io, as you were mentioning, to help people measure all that. You built it from the ground out, and then you merged with 8x8, and you had the aha moment of, well, if Google's asking this, if the Apple's asking this, this is something we can go out and answer. And there needs to be someone that's helping people measure that dedicated call quality and connectivity, and just ensuring that, and that scaled immensely in the pandemic.
Yeah.
So what was it like when you went from that startup environment and ended up merging with 8x8?
All journeys are kind of like bittersweet. So for me, it was when we built CallStats, we grew very rapidly initially. We had a bunch of like really good customers that used it. Some of the big apps used it. But before the pandemic, a few years before, what we noticed was that there was large-scale consolidation. Like that's the nature of businesses where, winner takes it all, and some other businesses need to like merge. So we saw a bunch of that happen. And what we started to notice is that it was not really collaboration, but call centers, like where people work, and call quality is an interesting aspect of their lives, where you have a call center which is receiving a bunch of calls. People are already calling that call center because they need some kind of help. And if call quality is an issue on the call, you're now grappling with 2 things. And we've talked about the pandemic where people work from home, but a few years before, when people were not working from home, call centers are usually a brick and mortar. Like there are, like an office, people come in and work, and that's great because you have IT departments which can make sure that you have nice Wi-Fi coverage. You're kind of like sitting in a very physical spot. You're not moving around, right? Like it's not like an office, like here, do the job, go back home kind of thing. Yeah. But then people started to work from home, even in those cases where for compliance reasons, for other things, people said, we can't get hundreds of people into one office. We need to have satellite offices, small offices. And the extension of that logic is you work from home. Your office at home becomes like one site for a call center. And the problems that we were seeing in those situations where they had these hybrid situations was call quality at the office was great, but if they work from home, was not great. And the problem with that is that, you could say, if you know that these people have bad quality, someone should fix it, but we should stop routing calls to them, right? So technically, what happens is that if you have like 1,000 people workforce, like attending calls, or let's say 100, right? And then 10 or 15 of them have like some situation happening right now, you only have 85 effective people. What happens then is that the calls that are coming into the call center have longer wait times, right? And then this becomes elastic because, there are breaks. People cannot take calls back to back. Like there are only n number of calls. So you have to it's a scheduling thing that people start to think about. And call quality becomes like, maybe your call was great in the morning, and now as you go into the afternoon, things are becoming worse. And this may happen because, you got kids back from school at home, they're playing video games, TikToks, whatever, right? And there are other environmental factors that can impact. So it's not like, if it's not set in stone, if you had good quality now, you'll have it in 2 hours. So that's where like a lot of the business started to grow. And one thing that we noticed is that selling a SaaS product to startups or to like high growth companies is different from selling to call centers. And the thesis started to become that, there's a lot of value, there's a lot of revenue, but the way to sell it is different. And a deal that would close normally like in 90 days or 100 days with other startups, fast-moving businesses, would be completely different for a call center. So, for example, you would have to go through compliance. Maybe there's a buying cycle. When is the budget available? A lot of those things come into play. And by 2019, the realization set in that for us to be like a bigger business, we needed to have more dedicated sales. And it's probably easier to sell an add-on, which is analytics, than sell it as its own product, because you can cross-sell it. So if you're selling, like if you are part of a call center suite, like someone who's already selling a call center, you add analytics to it. They get higher value for that, but also we have higher value in the sense that we can sell it more horizontally as opposed to. So I think it was more like a business realization. As much as I would have loved to stay independent, it was not like seeing like a viable way to get to the goals.
Just sort of the natural business life cycle of this is one of the calls you have to make, and little calls, that's a funny pun. It moves on from there. Yeah, incredibly interesting. And call quality is something users notice immediately when it's bad, but rarely think about when everything's going perfect, everything's going fine. They're not thinking about call quality. So from a technical standpoint, what are the biggest challenges in maintaining that high quality real-time video and audio over the internet?
Well, the thing typically is not only that, like people care about it, but a lot of the times they're like, oh, I just made a call on product X and then I'm using product Y and it's not working, or vice versa, right? And I think a lot of it comes down to the actual, like, one, network changes all the time. So you could be sitting here and you're connected to this Wi-Fi hotspot right over my head, for example. And then I walk 5 steps and I sit, just outside. And I'm still connected to this one and not to the one over my head there. And people don't realize that might be the issue, right? Or as I said earlier, like, you're working from, let's say, a shared environment, home, coffee shops, wherever, and the environment may actually be causing this. You might have taken a call 5 minutes ago and it was perfect, and then it isn't. So to your question, it's a time-varying situation. Environment plays an important role. And it's sad that, unfortunately, like a lot of it kind of falls onto like the end user to kind of think through all of that. Largely what we really want is like the apps to do this by themselves. Detect that you're having a quality issue, change the quality. And the tension is at 2 levels. 2 apps which are slightly different from each other will make completely different decisions for that, right? So let's say that's a screen sharing app. Your screen share, like if you're doing screen sharing, the pictures are not changing that fast. It's not, you're not moving your hand and you expect it to like render correctly. You're like, it's a slide. Slides will change whenever you stop speaking. The next slide will come. It should render fast, high quality. If it has letters, you need to see all the letters be legible. Those are completely different, like set of constraints, as opposed to you're doing a video call like FaceTime and you're like and especially like, for example, if you're outside and you call up your parents, for example, and say like, hey, I'm in Riga, see this beautiful thing, this building, and then that's a whole dynamic situation. Then the situation where we are in right now in a podcast where we have high quality cameras pointed at us and we're recording, and this could easily be going out live on YouTube or LinkedIn or wherever, and those folks would be expecting a slightly, like, would they want to hear us live? So the constraints are slightly different. So you have quality, you have what devices you have to capture, also what you're rendering, right? So if you're a phone, like, and you're watching it on a small screen, that's complete, like, you don't need to get full HD 4K video downloaded onto your phone just to see it live. And if you were watching a football game, that's a completely different, like, you don't want your neighbor to scream goal before you you're like, what? Like, which game is that, right? So so you want to, so those are the things that so the responsibility comes down to like kind of the apps. And what we try to make sure with WebRTC was that all the primitives were available, that as an API, we expose as much information as we can so that the apps can build whatever trade-offs you want to make. Of course, some of it is opinionated. WebRTC has some opinionated constraints into it, where you can't, like, for example, do certain things. Like it is meant for like live. So, it will try to do 30 frames per second or 15 frames per second, and will try to render them as fast as they can. It won't like do something like, we want to watch each picture like really well. So like buffer 1 second, for example, and then you're 1 second behind real time. But you'll always have like really high quality video in that case, because you're using that 1 second to like make sure that there are no artifacts in the video. But if your buffer is, 100 milliseconds, then there are different strategies that you have to employ. And we can talk at length, like what are the right strategies, but that's a whole different can of worms. Thing. Yeah.
I will touch briefly on WebRTC. Most of our listeners do probably know this, but for those who don't, WebRTC powers a huge portion of the internet's video calls today. And you, Varun, are considered a key figure in that space. So what does make WebRTC so revolutionary and used by billions, if not millions of people?
So it's an interesting one. The thing is, WebRTC, and people's opinions vary on this, is a set of protocol suites which have existed 10, 15 years before WebRTC came together. So most of the protocols, for the most part, existed. And there were like maybe 10 ways of like transmitting videos. You had like 5 different codecs. And the initial set was to pick some subset of these protocols and say, these are the ones that we would use in WebRTC. And I think that was like a very encouraging or the right step, because it allowed us to build, like stand on the shoulder of giants in some sense, right? Like people had already solved a lot of these problems before. We were not starting from a clean slate. There are, of course, challenges when you have new use cases that are built on technology that has been around for a while. You're kind of retrofitting. So maybe they didn't envision all the use cases that were imagined now. So you're kind of retrofitting into an old protocol. So it's not like basically square pegs, round holes kind of a situation you run into. And so there was some of those, but we did start from a set of protocols that already existed. And then there were things that we really wanted to solve, like, for example, security was a set of things that had not been really thought through in the 90s, was an emergent. We wanted to make sure that all calls were encrypted to the best of our ability, no eavesdropping, all that stuff. So a bunch of things had to be added to make these protocols more robust from a security perspective. Of course, the capabilities of codecs had also changed. What you could do in the early 2000s was completely different than what you could do in the late 2000s, early 2010s. What you can do today. So there's a bunch of like work we had to do to kind of get it all together. The new thing was actually the APIs, because there was no way for the browser to access your camera and to send video or UDP. Usually browsers could only do HTTP. So being able to do UDP was like considered like an interesting new thing that we brought, a capability that existed on the computer but not inside the browser.
That was really good. And then I guess from a QA perspective in this sort of world, we've been working with WebRTC, and we've talked about the environmental factors. Maybe someone moves and the Wi-Fi doesn't go to the nearest box, or the camera's not the right quality. When it comes to testing and benchmarking call quality, what metrics actually matter? Because there's a lot on the end user, and they have to make sure that the quality they want aligns with the hardware they've given themselves and the Wi-Fi they have, or the 5G. But how do you build resilient systems from the developer's end that you can do as much as you can on your end, and then the rest is up to the sort of end user in a way?
Yeah, there's I think the technical part is that there are lots of metrics that you can measure, but typically the thesis is there are only two things at least in real time that you really care about. One is how quickly can you send video and render video on the other side, right? So you would say like a timeliness metric, for a lack of a better word. So if you said hi, how quickly I hear that hi, or like if you wave your hand, how quickly does it render on my screen, right? So glass to glass, or that's like typically the latency that people talk about. And if you do something like YouTube, you have a lot more time. If you do live, you just have to be fast enough. But if you're doing real time bi-directional conversation, then what you want to avoid is like a walkie-talkie situation, right? Like where you say hello and then you wait for an inordinate time before the other party says hello, because like that's the contract you have, right? Like you can't start speaking more because if you've not heard any acknowledgement from the other
when
side.
you start a meeting, can everyone hear me kind of thing?
Yeah, or like if you say hello and if the other party doesn't say hello back, you pause, even if you know what you
just to be sure.
You don't want to start speaking and then realize that the other party was not
they didn't hear anything.
Yeah. So of course video makes it a lot more easier, because if you can see the other person, then you assume that they can hear you. So there are a lot, and you now have all those t-shirts that says the mic on, switch on the mic, or all that stuff, because those are like user experience issues. So timeliness is one, and then the other thing is what you would say quality. So if I'm sending 4K or like HD or VGA, whatever quality are you seeing? And the thing is that I could send like really high quality, but kind of depends on what you can see, right? And this becomes more complicated when you have more people in the call. And scenarios matter a lot. So like, for example, if it's a company all hands, there are like 40 people on stage or 20 people on stage that you can see videos for. What you really care about is like the speakers, and sometimes may not be the speaker. You want to like see the CEO's reaction, irrespective of like whoever's speaking, in addition to, right? Or board members, whatever. Like there are always your interests of whose reactions you want to watch may be different from like who's speaking. So in those cases, you have to think through as an app developer, like what is your use case doing? And then there are other things like you have networks that what is the capability of the network? What is the capability of the devices? How much battery you have, right? Are you going to run out of battery before the end of the call? Or maybe you want to save your battery. So, you have to like make some trade-offs. And those are all user settings in some sense. But user saying like, I'm in low power mode, then the app needs to like also adhere to like what the expectations are. So those are things that developers really need to think about. There are always all the hooks available. The question is how deeply integrated they are.
And it's not just limited to that, because there is a lot of new factors. The buzzword of the past last year, this year, probably next year is AI. And with the rise of AI, it's not just those human-to-human conversations that matter. We're seeing a rise of human-to-bot conversations. Audience is probably familiar with the early stages of that with Amazon's Alexa. You could say, oh, what's the weather today? What can I see at the weekend, et cetera, et cetera. But how far has sort of this AI voice tech come since then and now into 2025, 2026?
Yeah. So I think in the last couple of years, and if you look at, I think ChatGPT was the aha moment for a lot of us, because we had GPTs before and you could use them, but ChatGPT gave us an interface or a user experience that we're all familiar with, chat, right? Like you could chat with something and it responds, and you can have multi-turn. It's before that, like you could do multi-turn, but you weren't quite, like you could ask and it would give you answers, and then another conversation could happen. ChatGPT showed us like you could have multi-turn, longer conversations. It had access to knowledge, which we hadn't seen before, and it could string words together in a compelling way. You could argue like if it's the right thing or not, but like it could mimic a conversation really well. And I think this happened in 2022. So already in 23, we were like, oh, if you have something that can receive text and send text back, how difficult would it be to send voice, transcribe the voice to text, send it to the thing, sends back text, and convert that text to voice, right?
And get that back.
Yeah, and then you have a voice-to-voice conversation. And these things are now called cascade because you're cascading 3 models. Like you have a speech-to-text, LLM, text-to-speech. And I think we've always wanted to talk to computers. Like even our earliest science fiction, like Star Trek and stuff, you had computer kit.
Iron Man and his Jarvis.
Yeah, Iron Man and his Jarvis. We've had like people, we've known that we want to talk to these things for the longest time. And I think ChatGPT showed us that it can talk back, like it can chat back, right? And it has access to
knowledge.
Yeah, and you can add your own knowledge in different ways to kind of get you all the way there. So since then, I think what we've seen is iterations on it. The speech to text has become really better. They've become multi-language support, so you can speak in Latvian now, and it will understand it. The general GPTs can do that now. And then you have so you could transcribe. You can speak Latvian. It'll transcribe the Latvian, send that Latvian text to a GPT LLM. It'll send it back in Latvian, and then now you have text-to-speech engines which understand Latvian and speak Latvian back. And Latvian is such a small language, and it does it. So like think about English for sure, Spanish. Now you've got multilingual or bilingual ones where you can switch halfway through, speak Spanglish. Or speak English and Spanish. Yeah, and it'll speak back, or you speak Spanish. And you only understand Spanish, but the other party only understands English.
And it can help with that intermediary bit.
Yeah. So one side it just speaks Spanish, and the other side just speaks English, and it will translate in between. So you open so many use cases for this. Like in the simplest thing, you can build education apps, right? Like
language learning, maybe.
Language learning already, yeah, definitely. That's like, I think from a knowledge perspective, the LLMs have intrinsic knowledge that you don't even have to tell it anything. Yeah, you just say like, I want to learn a language, and it'll tell you how to learn the language. It'll help you as much as it can. It can also adjust to your level, right? And so I think those are kind of native inbuilt features. So language learning, any kind of, can you help me with X or Y, like history or any kind of subject? You don't really need to. You could argue if it's the right history and all, whatever, but like it already knows. It's trained on Wikipedia, so it already knows a bunch of these things. Can solve math problems, more and more. So those things, you don't need to bring your secret sauce in some sense. But if you are trying to do like healthcare or something around your own business, like a support bot, in those customer support situations, it needs to know your return policy. It needs to know your refund policy. It needs to know like all those policies which are like not generic, and you don't want it to hallucinate. It doesn't, like, if you don't have it, it should say you don't have it, not pick something from its general database of knowledge and say like, oh, I know that because company X, which is similar to yours, does it, maybe you also do it. It's not something that you want. So like those are the things that you have to care about. But so voice AI, I think we've always wanted to talk to computers. I think we are slowly getting there. There are so many problems you have to solve to get to like an end result, which is just like we saw on television or in science fiction. But every day we're closer.
As I say, that does lead on to my next question of what are the significant challenges that come with voice IA and those human-to-bot conversations? Maybe, as you mentioned, we've always wanted to, but are people ready, or do you think they'll still want to see the working of the AI and figure out how it decided on that?
It's I guess I think it depends on the use case. I think if you're building something, if you're a company which is deploying it, you want to know why it said certain things, and explainability is like really like the thing that people want to understand. But also there are evals. So if you know that this is the type of conversation that will happen, you run evals with variations of that conversation to see like does it always do the right thing. So I think testing becomes like really the most important aspect of it, because I think we're at a point where you could have a GPT, you could talk to it, it'll talk back. But what you want to do or see is that if you had thousands of conversations around the same topic by different people, would it result in the same kind of answers? And because we are using language, and especially as we speak, when you write, you're more like definitive in how you write.
Very good describing what you do. When you talk, it's shorter and quicker
and more fuzzy.
Yeah.
Right. Like when we talk with each other, like we have like some shared context, which we rely on quite a lot. So we don't specify in great detail to the extent you can say this, that, and you by context know what this and that would mean. But if you did that in chat,
it doesn't have that context. It doesn't know the room.
Yeah, it doesn't know the room. And if it goes, you will be frustrated if it goes off, and then you would have to say, no, I meant this. But there's also, like in chat, you have like some more flexibility. Like you have more space. When you put down thoughts, when you write, you actually think through. But when you speak, you don't have like the same kind of oversight, and you don't have the ability to kind of go and edit, right? Like I can't go back one sentence before.
No, you can't.
And like, I could just say, oh, wait a minute, I want to rephrase it and do that. But that would be so annoying. Like people like, hey,
every other sentence, like, wait, hang on, that's not what I meant.
Yeah, let me rephrase my own. And you're like, I can't keep context, because it was easier to like do it in a conversation, right? You say, oh no, I think, did you mean that? And like have that instead of me re-updating what I'm saying. But you could do that in text. But I think the challenges are, we want to get to more fluid conversations. I think in 2023, 24, the issues were around like, how do we make those cascaded models work really well together? You don't want latencies. You want to run, like while you're transcribing the speech, you start the LLM processing so that you can send the text so that the LLM can start to formulate an answer while I'm still speaking, for example. And when I'm done, it like as quickly as possible, condensed process
and comes through,
and then you have text to speech to like send speech back. So that was like the thing. And you have these three models. You want to like parallelize them. You could also run them all in the same space. But the state-of-the-art models are all moving so fast that you can't actually put them all in one place. So you end up having to call out separately, like it's a network latency. Like you have your own model, I have my own model, he has his own model. So like, at some point you have these three models that you're trying to like work with. You want to place your bot as close to these three models. You want these three models to be close to each other as well. So latency was a big thing in 24. I think we kind of got it to an 80-20 situation where it's good enough. The models will go around the world. Like all the best models will be in Europe, so that the European users don't have to like have that latency to the US. The same thing in Asia. There are also languages in play. So, like Europe has that diversity
German
of language.
And French and Czech and Latvian. And then in, I guess, Asia, you'd focus on Indonesian, Malaysian. And
all the Indic languages or Chinese and Japanese. So there will be a lot of that build out that will need to happen as a consequence of that. So the models will have to like go all over the world. Then you will have lower latency. So I think more or less, we are on that path now. Now I think it's mostly this year has been really around, as you have multi-turn conversation, especially with speech. Speech is not fully formulated in the sense that people are thinking while they're speaking, depending on like your use case. in those cases, like for example, in language learning, if I'm learning a new language, my speech may be actually much more slower. So the bot has to be very patient.
It also has to pick, maybe you haven't got quite the perfect pronunciation of the language you're practicing, and it has to know, okay, that's not quite how they say croissant in French or something.
Yeah, or also like, is the sentence complete, or you may be paused mid-sentence, so it can't actually interject. It has to kind of wait until your sentence is complete. And sentence completion is its own problem because, when we write, we don't end in prepositions, for example, with English, but when we speak, people may correct you and say like you ended on a preposition, right? And you're like, that's the call out, but that's how language is.
That's how it is.
And the bot has to know like the sentence is complete before it can like move.
Say, this is what you should say. This is how they say croissant. They
don't
say like that.
And language learning versus like if you're a customer support, you want to have a bot which listens to your problems that you're claiming.
The whole problem before you stop.
And then ask leading questions or whatever. So those are the things that we are thinking about that right now. Multi-turn conversations also have the problem that how much of the conversation should it remember? And if it's the conversation gets into like 15, 20 turns, does it remember like the beginning of the call? So now I think we call this context engineering. So you had the prompt engineering before, now you have context
engineering.
Yeah, so you have like 1 million tokens. You want to make sure that you use as much, but not all of it. As the conversation goes longer, you want to compress it. You may also want to keep a raw transcript on the side in case you compressed differently. Instead of asking the user, you just say, let me look up my notes. Humans would do this all the time. So a lot of the voice AI is now going to mimic human behavior, like how much knowledge it has. Does it need to pull knowledge from elsewhere? How to, like in a long conversation, how do we make sure that it remembers the right thing?
It doesn't get lost along the way. And I guess to give an example of this, one product you've worked quite closely with is Pipecat.ai. It's a product that positions itself as an open source framework for voice and multi-model conversational AI. Can you tell us a bit more about Pipecat, and maybe that adds to the context of what you were just talking about?
Yeah, that is. So thank you for asking. So Pipecat is an open source orchestration framework. It, as I talked about, these cascading models, or now we have these speech-to-speech models where you can send speech directly to an LLM and it will send speech back. So it has intrinsic understanding. It doesn't need to like transcribe from speech to text and then do that. It basically has native speech understanding. So the Pipecat is an open source, vendor neutral, so you don't have to necessarily use daily.
You're not locked in with anything. You can.
Even with daily, even though daily is like the main author of it, we now have hundreds of other companies like contributing to it. So we're at a point where we support something like 100 services, text to speech, LLMs, speech to text, best in class for many, in terms of latency, in terms of accuracy. We've also made sure that it's tuned to the point where these processes run in parallel as fast. We give more and more access to primitives. So when we talk about context engineering, you should be able to like keep context, update the context, compress the context. If you want to use multiple LLMs, there are concepts like LLM as a judge. So you have one thing that is just doing the conversation. There's another LLM which is looking at
a reviewer for the...
So like in the old world with the contact center, you have like the call center agent, and then you have a supervisor.
Just checking
which is eavesdropping on the conversation, right? So you could have like these kind of mixture of experts kind of thing. So you have like one person, like one LLM, whose main job is to just make sure that the conversation keeps on track. One, to make sure that it doesn't veer off and has guardrails around it and does not... you could actually say like, it's going to talk about refund policy. Here's what it's saying. does this match our refund policy? Right?
Is it accurate information?
Yeah, so it's like a triangle, right? Like the agent actually used the, like, called out, got the refund policy, is going to probably say something. You want to make sure whatever it pulled
is accurate.
Right? So, and you could do this for like ed tech as well, like language learning, as you're talking. You could say like, hey, there's one which is only going to, you are in this class or in this subject where it's teaching some certain words, but then there's another LLM that's watching and saying like, actually, let's go one step ahead, or we had this conversation 2 days ago, let's bring concepts from
let's reinforce that, grow on
and like merge these two concepts together. And so you don't have to have like one thing which is like doing all the grunt work and like making sure like it has all the right thing. Yeah. So, and you have like a bunch of agents, like, for a better word, like, which are putting this together. And then so you now start to see loops form where we're not talking about just the machinery around, getting speech, getting an LLM that one turn. We're now talking about multiple turns. And I think that in terms of where we're progressing with Pipecat is like, we want to make a lot of these harder problems easier. And we want to give, the low level stuff. So if you understand and you want to like go and play with the machinery, you can do that. But we'll also build like good opinionated defaults along the way, so that if you just say like, oh, I want to use 2 LLMs and this is what the second LLM is going to do, you don't really have to like formulate it. You just say, here are 2 LLMs, just configure them, and they'll like do the right thing.
They'll work together, they'll know what's happening.
And there'll be like a template which says like, see the output of the first one. You don't have to configure that, every output of the first one needs to be read by the second one. That would be implicitly assumed.
Known.
Yeah. So you don't have to code that aspect of it, and it's out of the box. So, time to value, if you're talking about like you're building more complex use cases where you need like all these kind of oversight and guardrails, they all come with like with batteries. Yeah. Right. So you don't have to go buy anything.
Batteries included.
Yeah. And you so get everything, you get it, get into the hands of like, let's say, testing or evaluations. And then you get to that aha moment faster. There will be a lot more tuning still to be done, but you can get to like 70%, 80%, 60%, depending on your use case and complexity. Right? If you're in healthcare, you maybe have like more things that you have to think about.
You have a lot more to check because of the regulations.
But if you're like saying,
an app does language learning.
You could just say like, maybe a very few guardrails, like just don't talk about X topics.
Just don't do that. So AI teamwork making the dream work.
Yeah, that is true.
Incredible. And I would like to look at the future by pulling on your past a bit. You spoke in the past at Demuke's 2023 about the heart of audio video innovation. 2 years on, 2025, going into 2026 and beyond, what's happening today that people aren't paying enough attention to? And is there anything you think that's going to be groundbreaking today, but it's just going to become normal expected behavior in the future from these tools?
So I'm really excited for voice being like a legitimate interface. I think like, to me, it's like mouse. We had mouse in the 60s, 70s. It only came together when the user interfaces came along. And like you had Windows 3.1, Windows 95, then Macs, and iPads. You basically got a whole bunch of things that followed because people started to envision how we could build or express information. So just like a mouse is like a pointing device, I think voice is also similar in that sense. And we're at this point where, because of deep learning and so it was already, we've had speech to text for almost 10 years and really good for, you brought up Alexa. We've been able to talk to Alexa for a long time. Has it been useful or not, apart from setting up timers and telling me the weather and like telling me how much time it will take me to get to
play
office?
Music.
But it can like it does understand it. It's just not been very useful, right? And we talked about science fiction TV shows and such. So we've always wanted to talk to computers. So I think we are at a point where if only the series and everything had more access, we would be able to like talk to our computers today, right? Like I don't need to open the to-do app to write a to-do. I could easily say like,
Add to my to-do list.
Add to my to-do list, and it could open the to-do app by itself and put everything that I said and put reminders or whatever, right? And then go out of focus. And then later on, like I could be doing something in Slack or whatever and say like, hey, could you like add to my to-do? And I think I'm done or whatever, right? And like to-do being just an example. So you could actually talk more and it could keep track of. And that's a really kind of hard problem because when we talk about context, it would have to remember different contexts, right? So like if you're inside Slack and doing something, that's a whole different context than my to-do context. And so there's layers like, oh, I'm writing an email. So if I want to talk, that's going to be the harder part of the problem is how do I keep and manage context for a generic system to like do what I mean.
Knowing what list belongs to that. Buy milk is on the shopping list, but remind me of this project is in a completely different thing, and it has to know the context of both of those.
Exactly. And that's just to-dos, right? So like it says like, oh, you got an email. What do you want to respond? And you say like, I want to respond this. You say it, and then you want to go see it before it's sent. You don't want to, if it's an important email, you want to still see like what was produced and like maybe edit it a little bit before it's sent out, and maybe that whole conversation needs to happen, and it may need to pull up while you're formulating all your email. It might say, actually, yeah, you know what, the last email was this, and a bunch of things. So depending on what type of product you're building, a generic voice interface is an interesting possibility where I think we've not explored. Like I think voice is now here. So I think to take it to its full capabilities, that's where I think we're going. Voice will become more part of the
mainstream.
I think it will become part of like as mouses. Like no one talks about like
it's not a revolution. It's like, oh, I have a computer mouse. You're like, cool. Everyone does.
Yeah, and that you being able to talk to a computer would be really like easy. And
if you're telling someone in the past I can talk to my computer, like wow, but you tell someone like in 2026, like yeah. Same.
And I think a lot of people are already like, meetings are getting transcribed. There's already a lot of like these small bespoke things that are happening. People are talking to their computers more and more. And even Alexa, like if you look at the latest Alexa update that happened this summer for Alexa V2, it's slower, but the responses are much more polished compared to like the old Alexa.
Much more than just recounting, it's sunny today.
Yeah. And you can actually have and I think probably we've also been trained a little bit with like using ChatGPT that we can actually ourselves hold a conversation.
What the AI needs to know that context.
Yeah.
It's not talking to a person. Fantastic. I will say it's incredible, but we are running out of time, unfortunately. So before we go, I do want to ask, how can our listeners learn more about you, follow your journey and the work you do?
Yeah, please go to Pipecat.ai. It is truly open source and vendor neutral. There are tons of examples, maybe 100, 200 examples there to build your whatever you're thinking about. I'm sure there are examples that can help you build anything you want to experiment with.
Want to play with.
Yeah.
Fantastic. So if you want to know more about Pipecat, you know where to start. But as I close off this episode, I'd like to thank you, Varun, for joining us today and sharing your insights. It's been great to learn from your tech journey and the knowledge you've gained from those 2 decades of experience researching, founding, leading, developing, experimenting, trying new things. And as mentioned, if you'd like to know more about Varun's journey, you can follow him on LinkedIn and you can give Pipecat a try. It's Pipecat.ai and it's open source, so it's free for anyone to use. It's vendor neutral. And if you want to learn more about making top-notch quality products, you can check out the TestDevLab knowledge base, where we have our blog, white papers, and of course, more episodes of Tech Effect. So Varun, thanks once again for joining us, sharing your insights, and thank you to our audience for joining us today, and I will see you in the next episode.